Welcome back to the series of lectures we have on quadratic functions. For this lesson, we are going to graph quadratic functions of the form y equals ax squared plus bx plus c. Remember, in the previous graph, we only graphed this quadratic function, and we had this 2. Now we have the middle term there. Okay, now I would like us to concentrate on this given here that we are supposed to have. We will solve first for the x-intercept, the y-intercept, vertex coordinates, and then before we draw the graph. Okay, example here. F of x equals x squared minus 6x plus 5. Okay. It will be easy for us to get the x and the y-intercept, okay? When we mean the x-intercept, if we have here the x and y axis, x-intercept would mean that y will be 0. At the x-intercept, y is 0 because it's where your graph will cross the x-axis. So, to get the x-intercept, here, we are going to set y to 0 and solve for x. Okay, so if we set y to 0, this becomes 0 equals x squared minus 6x plus 5. And this is factorable as this. X minus 5, x minus 1. Note that this is the quadratic equation. When you set this f of x to 0, that's actually the quadratic equation that you're familiar with, and they describe the x-intercepts of your graph. And by the zero product property, you get here x equals 5 or x equals 1. That's the x-intercept. Now, what about the y-intercept? The y-intercept is when our graph will cross the y-axis, and along the y-axis, x here is 0. So therefore, when we get the y-intercept, we will set what? X to 0 and solve for y. Okay, so if you have that, you get here y equals f at 0 equals, this is 0 squared minus 6 times 0 plus 5, or our y-intercept is 5. So we already know 3 information about our graph. We know the zeros or the x-intercepts and the y-intercept. Then the next one here, so this is number 1, and our number 2 is we will want to get the vertex coordinates. And we have shown that here we are going to complete the square here. Okay, so x squared minus 6x. What will be the third term to make this a perfect square trinomial? You get here 1/2 of 6 is 2, square that is a 9, and then subtract a minus 9 as well. Okay, and then this one is 1, so no problem. So we are going to group the first 3 terms, which give us our perfect square trinomial. And this is 9 minus 9 plus 5. And rewriting this as a square of a binomial, we get here minus 9 plus 5 is minus 4. So from this form, x minus 3 squared minus 4 equals f of x, I can identify my vertex at 3 and negative 4. Alright, the coordinates of my vertex are at 3 and negative 4. Number 3, the domain of a quadratic function is always x element real, unless you specify otherwise. And what about our range? We note that this parabola is opening upward because a is positive 1 Therefore, 3 and negative 4, the vertex is the lowest point. And if it is the lowest point, the lowest y value that we have is negative 4. And you're going up, positive infinity. So, our range will be from negative 4, including 4 here, up to positive infinity. Okay, now, for the equation of the axis of symmetry, we said that the equation of the axis of symmetry is derived from the coordinates of the vertex. And that will be the x coordinate here, there. That will be equation of the axis of symmetry. Here, equation of axis of symmetry will be equal to x equals 3. It is not 3 only. It should be x equals 3. Okay? And here, as a side note here, f at 3 is equal to negative 4. F at 3 is equal to negative 4. This is a minimum value. Minimum value there. Okay? So there's no more value that's lower than negative 4. Okay, now, for the symmetric point of the y-intercept, so let's get back to the y-intercept. The y-intercept is 5. Okay, the y-intercept is 5. We can have the symmetric point visualized better if we will graph now. Okay, so with this information, let's try graphing the given function. Let's graph the given function based on what we have had there. If I have here my x-axis and my y-axis, let's see, where are the x-intercepts? The x-intercepts are at 5 or 1. So we have here 1, 2, 3, 4, 5. So the graph will cross these 2 points here. 1, 2, 3, 4, 5. The y-intercept is at 5. Okay. Now, I can have my vertex located at x equals 3. And that will be y equals 4. 1, 2, 3, negative 4 there. Y equals negative 4, I mean. So, the vertex will be here. This vertex is 3 and negative 4. Okay. I will roughly graph my function now. Okay. Okay. This should be a smooth graph. It should not be a V shape, but that's concave. Concave there. Okay. There. That's the graph of the given function. Now, I will run a vertical line through x equals 3. That will be this one here. This is the equation of the axis of symmetry. Okay, that's the equation of the axis of symmetry. Now, the fifth question a while ago is, we want to get the coordinates of the point which is symmetric with the y-intercept. The y-intercept here is contained at the point 0, 5. Okay, so 0, 5. So, if I draw here a horizontal line here, this point here should have the same y coordinate, or that's a 5. Now we are looking for this other x here, because this other x is 0. Okay? So, going back to our equation, we can actually find what this x here is. Okay? Now, I can do it by brute force. The distance between this point and this one here is 3 units. 3 units away. So I need to get a point which is 3 units away from here. So 1, 2, 3. So this is 3, 4, 5, 6. That should be a 6 here. So I am guessing that this one should be a 6. Okay? So 6, 5. Now, to show that that is 6, we can get back to this. Okay? We can get back to the original equation. And we will make this equal to 5. Okay? If this one is equal to 5, I'll get here, that's y equals 5. And I will solve for x. So this will cancel off here. I get 0 equals x squared minus 6x, or x times x minus 6. From the zero product property, one of the x's is 0, the other one is 6. So indeed, we have a 0 here, and that's a 6 there. So these two are symmetric points. Okay? These two are symmetric points. So I hope that's clear. Let's have another example. Okay. For number 1, what will be my x-intercept? I can equate this to 0. So I'll be solving for the x-intercept. I will solve this equation, equate that to 0, and I can multiply everything by negative 1/2. This will give me what? X squared plus 6x minus 10 and 2 plus, this will be a plus 5 equals 0. So is this factorable? Yes, this will be x plus 1 times x plus 5 equals 0. And my x-intercepts would be x plus negative 1 and x equals negative 5. Okay. What x? 5x, 6. Now, what about my y-intercept? My y-intercept from here, my y-intercept, I'll just make this 0, I'll just make this 0, and I get a negative 10 as the y-intercept. Okay. Then, we are going to have the vertex coordinates. Okay, so we will solve for the vertex coordinates of this function. Okay, I'm going to enclose the first two terms in parentheses, and I'll factor out negative 2, so I'll get negative 2, and I'll have x squared plus 6x plus, what should be the third term that will make this a perfect square trinomial? Take 1/2 of 6 is 3, square that is 9. We add 9, we subtract 9. Okay? And our interest will be just the first three terms here. Here, negative 2 times x squared plus 6x plus 9. And then, plus negative 2 times negative 9 minus 10. And I can now rewrite this as negative 2 of x plus 3 squared. This is 18 minus 10 is 8. And this gives me my vertex located at negative 3 and 8. Now, our parabola is opening downward. Okay? Now, we will find out the domain. Again, this will be all reals except when you specify. And then the range here, notice that this negative 3 and 8, f at negative 3 equals 8 is a maximum value. Maximum value. Which means there's no more y that's higher than 8. Therefore, the graph goes down. So your range will be from negative infinity up to this maximum value of y. So from negative infinity up to 8. That is your range. Okay. And the fourth one is equation of the axis of symmetry. And this is always the x value at the vertex. So this is x equals negative 3. It's not negative 3 only. It should be an equation. Okay? And then again, the coordinates of the point symmetric with the y-intercept. Let's take the graph, so it will be better for you to look at the graph. Okay? Now, we have already negative 1, negative 5. So, I will have my graph here on the left. Okay. x is negative 1, negative 2, negative 3, negative 4, negative 5. So these two are my x-intercepts. Negative 1 here and negative 5. And then my y-intercept is negative 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my y-intercept is here. And my vertex here is located at negative 3 and 8. So 1, 2, 3. And I have 8. So this goes up here. Let's say 1, 2, 3, 4, 5, 6, 7, 8. And negative 3 is here. So that's 8. So I'm now going to have this graph here going there, and this graph here. Okay, so it's something like it's a very narrow graph. Okay, that's approximately your graph concave downward, and I have here my y-intercept. I need to get the coordinates of this symmetric point. Now, this line here is the equation of the axis of symmetry. This is x equals negative 3. Now, the coordinates here will be 0 and negative 10. This one here should have also a negative 10 as a value for y, because they are supposed to have, these 2 points are supposed to be symmetric with each other, so they have the same value of y. Now, I can do again a brute force way of identifying this x here by just counting how far is this point here from this. So that's 3 units. 1, 2, 3. So that's 3 units away. I need to get a point 3 units away here. So 1, 2, 3. And it falls on negative 6. So this should be a negative 6 and a negative 10. And how do we illustrate that? Using the given equation. Okay? We want to get the value of this one and that one using this equation. So when y equals negative 10, so this is negative 10 equals negative 2x squared minus 12x minus 10. This one cancels off, and I get here minus 2x squared minus 12x. And I can factor out negative 2x. This will give me x and plus 6. Okay. Hey. Now, from the zero product theorem, I get here negative 2x equals 0, or x plus 6 equals 0. And I will get here x equals 0 or x equals negative 6. Indeed, the coordinates of the point symmetric with this point containing the y-intercept is negative 6 and negative 10. Because the y-intercept is contained in the point 0 and negative 10. So, there you go. You can actually graph this one now. Any function in that form by just having this one here and plus k, for example. So in this case, we did a translation. There was a translation at x equals negative 3. You moved negative 3 to the right from that vertex, and then you went up 8 units up. Okay? So, this function was written as negative 2 times x plus 3 squared minus 8. So, there was a horizontal shift of negative 3 here, and then plus 8 here. Plus 8 going up. Okay? So, we were able to graph this using a primitive function where you just have to move this 3 units to the left and 8 units up. Okay? So, see you in the next video.